Now variables can have data types. So a variable is used to store a value that you want to use at a later time. And I know we've kind of discussed this already, but just want to refresh that if we could. You can think of this as the variable in math class. A variable like x can have any number assigned to it. It has a value. It's just a symbolic representation of a value that may change. That's why they call it variables. So variables have types, like for this case, greeting has the string printer, print stream, and here width is an integer primitive type, and we can set it directly to 13. That literal number becomes the binary representation of 13, and that gets stored in the width variable. I think of variables like a little mailbox. So you open the mailbox, put a value inside, close the mailbox. If you need the value later, you can open the mailbox, the variable, and grab the value that's inside it. Really, a variable is just a location in memory that's been reserved by the compiler to store the value of the variable. So here we have this object variable called greeting. Well, we can use that here in the place where you'd normally put a string. Since greeting is a string, it actually will print out hello world. So you don't have to put a literal in here. You can put a variable in here as well. That's what gives Java its power, is the ability to substitute variables where you'd normally have literals. Here we have our width is 13. Now we can just use the variable width. So what the compiler does, it says, okay, here's the printer object, and I'm printing out this line. What am I printing? Well, there's a variable here. So the compiler says, well, what data type is that? Oh, that's an int. So I'm going to call the print line that takes an int, and it will get the value out of the mailbox for width and give it to the print line method, which then prints it out. So that's what's going on behind the scenes. We're substituting the variable for a literal value. That way width can be any number you want. Say it changes over the running of the program, then you can just use width that way. It's an error to store a value in a type that does not match. Here we have string greeting, and we try to store in an integer, and the compiler will not like that, put up an error and say, hey, this doesn't work. So if you try to set a value or try to set a variable to a value that doesn't belong, it will not compile. So how do you tell the compiler what kind of variable you want and what its value should be? So you're declaring to the compiler, hey, I got this variable. It's an integer. It's called width, and it has a value of 10. Okay, that's how you tell the compiler, yeah, I want this variable that has this value. So it declares an integer variable and initialize it with the number 10. Now, this is called an assignment operator, and what that means is, notice I didn't call it an equals operator. It's an assignment operator. This is actually very active. So you take the thing on the right and store it into the thing on the left. So the thing on the right is 10, and we store it into this variable called width. So we open up the mailbox, stuff in the 10, close the mailbox, and then we'll use it later in our program. You can also, when you declare it, you can set it to an initial value, and that initial value might be the result of an equation. So say you're trying to get an area of a rectangle, you can just put the whole equation here on the right, and then you assign that to the thing on the left. So you have this variable up in memory called area. You open up the mailbox and you stuff in the product of width and height. You can't just grab a variable out of the air without telling the compiler the data type. So if you say height equals 5, it'll go, what? I don't know what height is. I don't know its data type, therefore I can't compile. Here's another one, int height equals 5 in quotes. It sees this as a string, but data type of the variable is an integer, so the compiler complains and say, hey, this doesn't make sense. You can't initialize an integer with a string. Notice, even though it's a numeric string, it doesn't count as a number. It's actually two different values. 5 in binary is different than 5 in ASCII. ASCII's hexadecimal equivalent is 35 in base 16. So two completely different concepts. One's a string that happens to have the digit 5 in it. The other one is actually 5, or literally 5. If you have a bunch of variables that share the same data type, you can Just provide the data type and then separate all the variables with commas. Now, evidently in this book, the author doesn't like doing that. And so he would type in int width, int height. But if you have a lot of them, it gets a little tedious. So programmers are notoriously lazy when it comes to typing. They want to type as few characters as possible. C programmers are the worst. The more obfuscated and opaque the code is, the better. It's called job security. Okay, so identifiers. And this is a very general word. What is an identifier? And basically what it is just a name. You make names all the time in your coding. You name variables, you name methods, you name classes. Those are all identifiers. But there's rules when it comes to identifiers. Before you can put it in your code, you have to follow these rules. So here's the first one. Identifiers can be numbers, letters, and the underscore, and sometimes a $sign. That's kind of interesting, that one. Not sure why that's included. So you're pretty limited. You can't use any special characters other than the $sign and an underscore. You can't put an @ sign there. You can't use an exclamation point. So the rules for coming up with names for variables, methods, or classes is rather limited. You don't have the whole keyboard to work with. Another thing that catches a lot of beginning programmers is you can't start with a digit. So if you start with the number or the digit 5 and you say 5 or like 4, so you couldn't put the number 4 at the beginning. Okay. So if I wanted to create a variable name like that, 4 and then the word candles all smashed together, that wouldn't count. You can't use special characters like we said, so you can't use a % or a question mark. This is the one that always catches students, is you can't put spaces inside identifiers. The compiler views those as two different things and then gets all confused about what it's supposed to be. You'll find your compiler is pretty stupid. Okay? You have to be very unambiguous when you tell the compiler what to do. If you put spaces in your variable names, it makes sense to you. The compiler's dumb as a stump. You got to learn how to talk to your compiler, and it's really, really not very intelligent. A lot of people think computers are smart. They're not. They're stupid. They only have a 45-word vocabulary. You have to, those 45 words, you have to get it to do what you want, and you'll find the compiler is really, really limited, I guess. Also, with identifiers, you can't use words that are already in the Java language, like if, switch, and int. You can't call an identifier an int. That's already been used by the language. So those are all off limits. Finally, identifiers are case sensitive. That means uppercase and lowercase are two different things. You have uppercase pig, let's say, P-I-G, all in capital letters. Lowercase pig, all in small letters. Those are two different things. Even though they say the same word, it's two different identifiers to the Java compiler. Now, by convention, variable names start with a lowercase letter. What does that mean by convention? Is there a convention that I go to where they define all this stuff? What that means is just generally, right? Programmers around the world have decided that, hey, we're always going to start our variable names with a lowercase letter. I know the language or the compiler doesn't enforce that, but it makes the code a lot easier to read. The only thing you ever see capitalized with the first letter is something called a class. Everything else, or most everything else, starts with a lowercase letter. I prefer to use Camel Case. It used to be like old C programs, you can tell them because they put in a word, they put in an underscore, and then the word again, another word, as part of the identifier. So if you see that, that's an old school programmer like myself. But I prefer something called Camel Case, where you start with a lowercase letter and any subsequent word you start with an uppercase letter. So farewell message. Message is capitalized. Also by convention, class names start with an uppercase letter. We'll learn more about what a class is, but for now, just make note of that, I guess. Finally, we get an answer to our question, the $sign. What is it used for? And there's a lot of stuff in NetBeans where you press a button and it automatically creates code for you. And in a lot of those situations, it wants to not pollute the namespace with a bunch of words that you might be using in your own programming. The way they avoid that is they put a $ in their names so that you don't get any name collisions when you're working on your own code. So here's our variable declaration. Now, did we make a syntax card for this? We did, right? If you missed today, I have cards back here. This is what we're putting in our this is what we're putting on our syntax cards. So far we should have 3, right? Or just 2? We have 3, yeah. So if you haven't made the syntax card, there is it again. Here's some different variable names in Java. Farewell message. It's in Camel Case. That's a good one. X. Yeah, I guess that's a variable. But in Java, that doesn't really tell you a lot. It makes your programs hard to understand. What does X represent? Is it a coordinate in a Cartesian coordinate system like you would see in math? Or is it just some variable that you decided, I don't really need to name this, I'll just call it X? The human reader comes by later and says, well, what's X? What does that stand for? Why not just use a name like X coordinate? And that would help you understand, oh, this is actually an X coordinate in a Cartesian system. So you do this a lot if you're a Java programmer, variable names like this, and you don't keep your job very long because it makes the code really hard to understand. Make sure you make your variable names descriptive of what it's holding, and then it's not a problem. Here's greeting. Variable names are case sensitive. This variable name is different from greeting, so just pay attention to that. If you had a lowercase greeting, that's a different variable in a different spot in memory. Here's a few error ones. 6-pack with the number 6 at the beginning. You can't start with a number. The compiler's going along, grabs this next token and says, oh, it's a number. Starts with a number, so I'm going to make this a double. Or I'm going to make this an integer. And so you put the number at the beginning, and the compiler's like completely flummoxed because it doesn't know how to convert that into a number. So you can't start with a digit. The digit can be later on in the identifier, but it just can't be the first letter. Here's another problem, farewell message. It's got a space in it. The compiler will see this and have no clue what to do with that. Here's another one. You can't call an identifier public because public's already reserved by the language. It's called a reserved word, and therefore you can't use it because it's already being used, I guess. So I don't see a lot of people taking notes. Again, these slides are not out on the internet, but this presentation is. It might be good to jot some things down while we go through it. I know the videos are going to be online. So which are our legal identifiers? Reading 1. It's got a digit in it. Question is that a bad identifier? Well, since it doesn't start with a number, this is perfectly valid. However, it doesn't follow the conventions that we talked about. If this is a variable, you'd have a lowercase g here. Only things that have an uppercase are classes, and this doesn't look like a class name. Is G a valid identifier? The answer is yes. However, it's frowned upon because it's not descriptive. How about an identifier called void? Well, it's lowercase, doesn't start with a digit, there's no spaces in it, must be a valid identifier. Yeah, it's reserved for the language. If you remember our main method, public, static, void, main string arg, but you see the word void all the time. It's part of the language, so that means you can't use it for an identifier. Here's 101 Dalmatians. Yeah, not such a great movie. Really bad identifier because it starts with a digit. You want that to be at the other end if you're going to do it. Compiler will see the number, try to convert it into an integer, I guess, and then fall on its head. Here's hello world. Is that a valid identifier? So let's look at it. Commas aren't allowed. Spaces aren't allowed. You probably try sending that in, and it's not going to work. Here's another one. We're using angle brackets around a bunch of letters. Is that a valid identifier? The answer is no, because it has special characters in it. The less than sign and greater than sign aren't allowed in the list of characters that you can use for identifiers. So only the first 2 are valid. The rest of them are invalid. Define a variable to hold your name. Use Camel Case in your variable name. Now, why do they call it camel case? I guess I didn't talk about that. You know how a camel, there's one camel that has one hump, there's another one that has two humps, right? And so if you look at the variable name, since it starts with the head, and the camel's head is small, and then it goes up one hump, then over the other, if you look at the variable, it looks like a camel, if you would draw an outline around it. So that's why I use the term camel case, because it starts with a lowercase letter, and then any subsequent word starts with an uppercase letter. So here's a string. Since your name is a series of characters, we use a string data type. Use camel case for the variable name, and then we use a string literal to set the value. Now, name is a really bad variable name. It's kind of like password being your password. What's your password? Password. Like that's the worst password ever. Well, not quite the worst. 1, 2, 3, 4, 5, 6 is the most common, I think.